Okay, so we're looking at the booklet and we'll look at the first paper. I hope this will help you through it. The first question on car parking, and we're given the cost of parking for short-term, long-term and park and ride, and we're asked to fill out the long-term up here, that middle section, and it's $3 and then increases by $6 over each hour. So we're just adding $6 every time to the long-term parking. That's quite straightforward. And then we are on the axis below, I'm sorry, the graph didn't come out here, but we plot the long-term parking charges. I've done that in purple there from the table. Now, we also notice when you plot that, when we get up to $39 is the maximum, so at the top of the graph, it straightens out. It just continues at $39 at the top, so that's the only thing to be careful of there. We need to write an equation for the park and ride. So when we look at the park and ride, that last column, we're adding $4 every time. So we're going to be 4 times the number of hours. The cost is going to be 4 times the number of hours. And if I go back to the first, I look at 4 times 1 is 4. If I have a look at this line across here, for 1 hour, it's going to cost me $9. So 4 times 1 hour is $4. I need to add another 5 in order to get to $9. Does that rule work for 2 hours? 4 times 2 hours is 8, plus 5 is 13. It will work out, and I've got $13 over there. Okay, the next question. Mr. Myers is going to the airport to see his son off. He wants to park between 2 and 4 hours. So when I look at the table, I'm going to just look between 2 and 4 hours, and I'm only considering short and long-term parking. So for 2 hours, long-term is cheaper. For 3 hours, long-term is a little bit cheaper. For 4 hours, short-term is cheaper. So which option would you recommend? So for 2 and 3 hours, from the table, you'd write this out in sentences. For 2 to 3 hours, then long-term, we would recommend. For if the plane was delayed and I knew I was going to be there at least 4 hours, then I would go to short-term parking. But the crossover is approximately, if you look on your graph, the crossover or the intersection crossover is, I think, at about 3.5 hours is the point where the difference comes. Okay, how does the rate of park and ride compare to the others? So park and ride is the green one. So when you're comparing here, I'll write it in black, you need to compare the starting rate. So park and ride is more expensive, okay, so you compare the start of the rate. Park and ride, the green line, when I look at my graph, the green line is above the purple for starting. So it's more expensive than long term to start, but it's less expensive than short term. The green line starts below the blue line. So we compare the starting point, and then we compare the rate of increase. Okay, so we look at the gradients or the rate. How steep are those lines? We're comparing with the green line. So the purple line, the long term, goes up. The rate is faster. The price increases more steeply. when I compare the green line, the park and ride, with the blue line on my graph, the short term, they're going up at the same rate. Okay, and I think that's enough to talk about. Those are the two main things. When you're asked to compare, always remember to compare the starting point, compare the gradient, and for excellence or merit, you could actually work out the gradients for those lines. You can see the blue and the green are parallel, and so they will have the same gradient. And you can give where they cross over the intersection points as well. So the next question is actually comparing a new company, Park and Go. Now they are at $8. They have a pickup at the airport for $8. And let's have a look. That's the only charge. They're not going to give you another charge for the first hour, and I think it comes to just under this green line. So if they charge anything under $4 an hour, if they add to that, if they charge under that, they will be under the green line. So they can charge an initial $8 for up to the first hour, and then I think it's under $4, they will be undercutting the other parking. The next question. So we've answered this page here. We'll go on to the next page, to the airport with the first hour free. So if I go, and we're looking at a parabola, from the graph we find the coordinates of the intercepts. Intercepts are everywhere that crosses the x-axis and the y-axis. Now it's asked for coordinates, so it must be written in brackets: 2 across, 0 down, -3 across, and 0 up or down, and 0 across and -6 down. Coordinates must be in the brackets. The equation of our parabola, we can just write the equation in factorized form, and we are on -3, so x plus 3. If x is -3, plus 3 would be 0 to make y 0, and x minus 2. Now, to find out what a is, I know there's a point 0 when x equals 0, y equals -6. So let's put x is 0 in both of those parts of the equation. So my y is -6. So -6 equals a times, when x is 0, that's going to be 3 in that bracket, and it's going to be -2 in that bracket. -6 equals a times -6. So my a value is actually 1. I don't need to write an a value for the equation. So the equation of my parabola is just a standard parabola. It doesn't have an a value that we need to write in. Works out like that. Now we're moving our parabola 1 unit to the left. So remember, inside the brackets it's a +1 if we move it across to the left. So we're going to add 1 and add 1 into that bracket. So y, I'll write down here, y equals x plus 4. We're moving it 1 to the right. Oops, done that right. The parabola is moving 1 to the left, and so it's +1. And this bracket, x minus 2, becomes x minus 1. And then I go 4 units up, which will be a +4 on the end. And the y-intercept is moving left 1 left and up 4. So we can just follow that on. Okay. an archway, and they've given you the equation of the archway for the railway station archway. And so I just write a little table to help me find the points on my graph. So it'll be 1, 8, 2, 14, 3, 18. If I put 4 in, be 20, 5, 18. And plot those. 1, 18, 2, oh, 1, 8, sorry. 1, 8, 2, 14, 3, 18, 4, 20, 5, 18. Oops, no, I've done that wrong. It's 5, 20. 5, 20 and 6, 18. 5, 20, 6, 18 again. And then down we go. So we've got that shaped parabola. Sketch the graph on the archway on the grid below. So that's what we do for that. And the next, we've sketched it. What's the maximum height? So you can see the maximum height will be here between 4 and 5, and because it's symmetrical, x is going to be 4.5 to give us the highest point. It doesn't go straight across at the top there, it is a little bit higher. So when x is 4.5, y equals 4.5. 9 minus 4.5, you can just put that into your calculator. So the maximum height, when we do that, will be 20.25 meters high. That's the height of the middle of the parabola. Now they're going to put a support 8 meters above the ground. So if I go to 8 meters above the ground, that would be a horizontal arch support there. What length is required? So what's the length between there and there? Well, on the graph it goes from 1 to 8, so that arch support would be when y equals x equals 8. When x equals 8, we can put that, when y equals 8, y equals 8, 8 equals x, 9 minus x. We can work that out. 8 equals 9x minus x squared. If you want to do this, I'll do this down the side here. If you want to do the whole equation, so we end up with, we can rearrange that to x squared minus 9x plus 8 equals 0, and we'll solve that. We'll have x minus 1, x minus 8 equals 0. So our values of x could be x equal 1 and x equal 8. So the distance between them, the length actually, is going to be 7 meters. Between, so I got that wrong there. The length that's required needs to be 7 meters. So between x equals 1 and x equals 8 is 7 meters. Next question. The last one about the gardening. So we do a table, we can fill it out there. We find the rule for the table. Remember, when you look at this, you're adding 4 each time. So we have to multiply n by 4. So p equals 4n. I look at the first n is 1. 4 times 1 is 4, but I have a 6 there, so I've got to add 2. That's my formula. If I have 400 paving slabs, so P is 400, so I can go 400 equals 4n plus 2. Dennis predicts he'll need 400 paving slabs. He wants 100 flower beds. Sorry. So if n is 100, up at the very top here, he wants to create 100 flower beds. So if n is 100 in here, P must equal 402. So if he only gets 400, he's going to be 2 short. There. The next, sorry, on this tablet, the pages are a bit funny. Bindi is also making a garden. What's the rule for Bindi's? So Bindi is adding 5 each time. So the number of paving slabs is going to be 5 times n. 5 ones are 5. And if I look in my first column, when n is 1, p is 3. So 5 times 1 is 5. I have to take 2 off that to get to 3. And we can draw that in a graph and in E. We can compare Bindi and Dennis. If you graph both of the amounts of slabs that they need for the gardens, and there's a ratio of 8 to 7. So if I did 8, I'll do it at the top of the page here. If I multiplied everything by 8, 8p equals 32n, and I multiply the 2 by 8, it's 16. That's the equation for Dennis. And for Bindi, let's multiply everything by her formula by 7. 7p would equal, multiply the other side by 7, 35n minus 7 2s are 14. And this is a ratio, so 32n plus 16 is going to equal 35n minus 14. And I can rearrange this. Let's put the, I've got the most n on this side, so let's leave that there, 35n minus 32n. And I've got 16, this minus 14 becomes a plus 14 on that side. So we have 30 equals 3n, then n must equal 10. Remember how to rearrange when you've got x on both sides of the river. So when n is 10, then the ratio of Dennis to Bindi is 8 to 7, because I've multiplied Dennis's equation by 8, and I've multiplied Bindi's by 7, so this is when they are equal, and I've worked out how much n would then be. Okay, I think that's it for that paper.